So we have some problems that we're solving using the quadratic formula, and students tend to make mistakes on these particular ones where they have to simplify. So I wanted to do two examples with you. So the first one is x squared minus 8x minus 23 equals negative 7. So we're going to go ahead and put that in standard form to start. And so when we put that in standard form, we're going to get x squared minus 8x, and then when I add the 7 to both sides, I get a negative 16. Okay, and we're going to solve this by the quadratic formula. So my a is equal to 1, my b is equal to negative 8, and my c is equal to negative 16. And then we know the quadratic formula, of course, is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so we're going to use that formula and we're going to substitute in the values that we have for a, b, and c. So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I always write mine like this and then I fill them in just to make sure that I'm getting all of the signs correctly. You do not have to do this in the detail if you don't want to, but I tend to do this, especially if students are making mistakes. I don't want them to get stuck. So looking at this, I end up getting x equals 8 plus or minus, and this gives me 64, and this gives me plus 64 over 2. So here's where a lot of mistakes are made. Students are like, oh, I'm going to go ahead and cancel the 8, reduce the 8 and the 2. You cannot do that because you need to make sure you simplify this radical first, and you have to reduce 3 values. You have to use 3 values when you're simplifying. There's nothing here but a 1, and 2 doesn't divide into 1. So it's like, the way you're looking at is you're saying, can I take 8 over 2? This is 128 over 2. So that's what we basically have. We can write it as the real, the irrational part and the rational part separately. But I don't usually split them apart like this. But I wanted you to see that we can't just cross off this 2 here and ignore that we haven't simplified this to reduce that portion of the answer. So if I cross off the 2 here and I don't simplify this first, I'm not getting an equivalent answer. Okay, so it's not equivalent. So let's go ahead and simplify this. I said that we have 8 plus or minus the square root of 128 over 2, and 128 is the same thing as 64 times 2. So if I have the square root of 64 times 2, and I want to simplify that, the 64 is a perfect square. I'm out of space, so I get x equals 8 plus or minus 8 times the square root of 2 over 2. And so what I want you to think of when you are simplifying, when you are reducing, think of this as kind of like a triangle. These are the 3 things that have to reduce. That 2 has to divide evenly into both of these numbers. Otherwise, you'll have to split them apart and write your answer separately. Right, this portion and this portion. But 2 does divide evenly into both of those, so we can reduce this. And we get x equals 4 plus or minus 4 times the square root of 2. And there's my answer. Over here, if you would have reduced, you would have gotten the wrong answer. You would have ended up getting 4 plus or minus the square root of 128, and you never would have reduced that 8 to a 4. You would have had an 8 on the outside. So it's really important that you, when you go to reduce, you don't cancel out this here because you still have this portion that you have to reduce. So wait until you simplify the radical before you start saying let's divide a 2 into both of these parts. Okay, I hope that makes sense. We're going to do one more example. So go ahead and put this in standard form. Identify your A, B, and C. And then go ahead and put it in the quadratic formula, because we're solving these using the quadratic formula. So that's what I get in standard form. I think it's good to identify your A, B, and C, because sometimes students know the formula, but they're substituting in the wrong values, and so they're getting the incorrect answer. So my A I got was 4, my B I got was 12, and my C is negative 13. I hope that you got the same thing. Yes. No, because we have a negative 4 here. If I subtract 9, I get negative 4 plus a negative 9. Okay, but thank you for asking, because sometimes I make a mistake, so good for you to check it. Okay, so now that I know my A, B, and C, I'm going to go ahead and set up my equation. Notice it's not x equals, it's v equals, because our variable is v, and I expect you to use the correct variable. So v equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so 12, 5, 5, negative 13. Okay, so as I proceed, I get v is equal to negative 12 plus or minus the square root. This is 144. This here is, I don't know, plus 206, or if you put that all together, I feel like that might not be right. Let me try that again. 4 times 5 times 13. Yeah, it's not right. I must have transposed that. 260. Now, if you wanted to just add those together and write it as 404, that's fine. Sometimes students make mistakes there, and sometimes it's better to do it separately if you're one who makes mistakes. Okay, so get this, and I get 404 over 10. Again, the mistake here would be to reduce that 6, that 12, and that 10 and make it negative 6 and 5, but then you forgot about the 404. So remember, you're always wanting to, if you want to reduce, there's got to be a number here, and here that you can reduce. So can we simplify that radical? So right away I see that 4 goes into 104. So, to 404. So I'm going to look at this as negative 12 plus or minus 4 times 101. And now I can simplify that. 4, square root of 4 gives me 2. So I get v equals negative 12 plus or minus 2 times the square root of 101 over 10. And 101 I can't simplify anymore. You could try if you want, but there's nothing that I can simplify to make it a perfect square factor. So at this point, I can now look at the negative 12, the 2, and the 10. And I can reduce that. So 2 goes into all of those. 2 goes into 2 once, 2 goes into 10 5 times, and 2 goes into negative 12 negative 6 times. So our answer comes out to be v equals negative 6 plus or minus. The one that's there you do not have to write, because 1 times 10 is 10, 1 times the square root of 7 is the square root of 7, 1 times the square root of 101 is the square root of 101. So I do not need to put that 1 right here that you see. It's understood. And there is our answer. Remember, you can write it like that, or you can write it separately if you want. If you want to write it like this with those squiggly brackets, you can. Either way, someone asked me that after they went to do homework, and I did mention it, but I wanted to mention it again because if one person asked that question, there was probably someone else who had that same question. Okay, so